afternoon. Thanks for attending. My name is Jason Bock. I'm a practice lead for application development in .NET at a software consulting company called Magenic. And my talk in this session is called Blazing the Web, Building Web Applications in C#. So you can find out more information about myself at these links. If you have questions, please feel free to raise your hand, get my attention. It's a little blinding with the light, but just if I don't see you, yell at me or whatever it is. And please ask them, because I'd like to have a conversation rather than me just talking. If you do have questions, I'll try my best to answer them. Otherwise, if something comes up later, feel free to send me an email, jasonb@magenic.com. All the code for the demos that I'm going to be doing is up on this repo. The one thing right now is what I'm going to be showing is Blazor client side, and that's currently in preview mode. So if you want to use this stuff and you want to try out all the demos, you need to have .NET Core 3.1 installed, you need templates, and you probably want to use Visual Studio 29 Preview, okay? As I'm going to talk in a moment, this will eventually become a full supported in-the-box type of thing. That's a couple months out down the road, okay? But if you just even want to look at the source code for the demos, all of it's there, and this link is on the next slide and the last one. So I'm going to talk a little bit about the history of web development, how we kind of got here and what WebAssembly and Blazor are. Then I'll spend a little bit of time going through WebAssembly and doing a small demo on it just so you can see what it is and what Blazor is actually built on top of. I'd say pretty much the majority of the talk though is going to be on Blazor, how it works, and doing a demo using Blazor client side, because that's actually the cool thing. And then end with some final thoughts, another demo on this idea of WebAssembly maybe potentially being the way that we do cross-language interaction, and then we'll wrap it up at the end. Okay? So, JavaScript. Slow. I know. I was like, is that a slow clap because you really didn't like that I did that, or is it nobody booed, so I guess that's good. And don't do it, please. This is a little snarky. I will admit it. This is a little kind of a dig. And truth be told, I don't hate. Okay. I have a love-hate relationship with JavaScript. I've done in the past. I've built apps that have serviced millions of users in that application, and a lot of it written with some pretty interesting JavaScript, well before the jQueries and all that other stuff. It is an interesting language in terms of its dynamic capabilities and some of the things you can do in it. I was kind of actually amazed just how powerful it could be at times. But at its core, JavaScript was designed and intended to be a scripting language, and that's not meant to be a cut or an insult. There's nothing wrong with the language fulfilling that capability. Its intent was to make it so you could build web applications doing more than just what was available with HTML and CSS, extend it a little bit. I've done apps where I use, in the past I've done it where I've used VBA in an Office app, and VBA is not a friendly language. But I was able to, and you could do this really neat trick where you could go into Word and then record a macro and then do all the things you needed to do, stop the macro, look at the code and go, oh, that's how they did it. And then you just run that macro and you amaze the user. You're like, how did you do all this? Totally all on me. It was not because I just recorded a macro. Okay? But doing stuff in VBA allowed me to extend Word to do things that the users needed, and it ended up with some pretty powerful results. Same thing with JavaScript. The unfortunate thing is, as the web became more and more popular, I'd say one of the primary reasons is because you don't have a store, you don't have an app store. Anybody can develop an app, deploy it, as long as you can host it on a server somewhere, you're good and you're golden. Okay? There's a lot of freedom there in developing a web app. And as that option became more and more available and more of a real option, it got more popular, and you had to kind of write more JavaScript. And as I started to do that, it did start to feel like this. It became unwieldy, became hard to manage, became hard to make sure that I wasn't inadvertently doing something wrong. And I think this is indicative also of the community in JavaScript because they started building 5 billion frameworks to make sure everything works correctly. I'm sure as I've been sitting here, there have been 10,000 new packages added to NPM. Again, that's a little snarky, but it was done, I think, for good reason, to build frameworks like jQuery. I think that was a catalyst when it first came out because it finally got rid of or tried to minimize all of these weird things between the browsers that were good and IE and made it so you didn't have to worry about that stuff, okay? And then as they got even more and more popular, we see frameworks like Angular and Vue and Aurelia and other frameworks that don't necessarily have to do with UI concerns, like Moment. If you've ever used dates and times in JavaScript, you really want to use Moment.js. Just like if you're in .NET, you really want to use something like Note-A-Time because date and time in .NET arguably doesn't cut it, okay? And this package Note-A-Time handles cases with time zones that can make your head spin. Okay, same thing with Moment. Lots of these packages are made. And what's really amazed me about JavaScript is the reach that it had. Way back when I started as a developer, this thing called Java came out. And one of its taglines was, write once, run everywhere. And that never really fulfilled its promise, arguably. I'd say JavaScript has gotten closer to that promise than any other language. The fact that it's not just for the browser, that it's in middleware, it's in back-end databases. It's quite impressive just how far this has reached. But I also have to question, why did this happen? Okay? I have talked to developers that work in other languages. And I know when I've asked them, if you could program in the language that you like, would you do it? If you could program the web in like Kotlin or C# or something like TypeScript, which is JavaScript with a lot of extra typing sugar, so to speak. Would you do that? And I get some answers that are always somewhere along the line of yes, okay? If you look up on the internet and just look up transpilers for JavaScript, you're gonna find a lot of projects, a fair amount of them that are just experimental skunkworks types of projects, but where they're trying to take language A and transpiling it into JavaScript, apparently because they don't want to program in JavaScript. I've noticed this, I've seen this, where people are like, I like this language, and it's not like I don't want to learn other languages. I'm currently looking at a language called Pony. It's kind of an interesting language, and it has some pretty cool capabilities to it. There's goodness in learning different languages, but I think there are other languages that do a better job overall than what JavaScript does. Adding strings and numbers where you get these bizarre results of what comes out of that equation just mortifies me. I don't understand the logic on some of the things JavaScript does. So could we do this? Could we have, this is not real code, but could we have something like this where I could actually write C# or write Ruby or write Python in the browser? And up until about a couple years ago, the answer was no, of course not, you can't. You have to use JavaScript because that's your only answer. That's been really weird for me. You see all these different languages. You see all these different runtimes, all these other targets, all these other operating systems, and pretty much you can use whatever language you want wherever you want, okay? Except for JavaScript, okay? And I have to admit, that's a little bit of a misnomer because JavaScript, you could use it and you can run it in Windows and Linux. But my point is, these other languages, well, I do have the arrows there, the other languages don't go into the browser up until a couple years ago. So that's one thing is choice. It's one thing of what language do I really like. The other one is performance. When JavaScript first came out, and for many years, it wasn't designed, it wasn't implemented to necessarily be a powerhouse and have really blazing high-speed performance because it didn't have to. And as it became more popular, that had to change. So people that work at Mozilla or Microsoft or Google to make the virtual machine and the runtimes for JavaScript and the interpreters in the browser work better, they've done a tremendous job, absolutely. But if you even talk to people on those teams, they'll say, you can get close to near native performance, but you will never get there in JavaScript. You will always have some measurable difference in cases where JavaScript just won't get there. And you may say, all I'm doing is building business apps. All I'm doing is, line of business apps where I'm doing CRUD type of stuff. I don't need to build a game. I don't need to have, GPU enhanced performance in my application, which I say to that, understood, makes sense. But if you could build upon a platform that is inherently just a little bit faster overall, wouldn't you pick that? Wouldn't you want that? I would. I think that's a good idea. It sounds like a good value proposition to me. And as developers are wont to do, if there's ever a limitation, if there's ever something they're like, could we do this? Somebody somewhere is going to do it, okay? And I love that about developers. They're tenacious. They like to try things and go beyond what any limitations are there, whether they're true or just, cooked up, and you really can go farther beyond what's there. So something called ASM.js came up, and long and short of ASM.js is if you use it, you actually are creating JavaScript that is real JavaScript. If you look at it, it's horrendous and horrible. The intent is you're not supposed to look at it. But if you target ASM.js and you go through tool chains that are like mscripting, the intent is you're supposed to be able to take code like C and C++ and end up with this really performant, efficient JavaScript code. That again looks horrible, but then you can put a demo where you can run Unreal in the browser. Okay, so if you look at that YouTube link, this was an experiment where they took Unreal Tournament, ran it in the browser, and it's actually impressive. It's really cool to see this run against ASM.js. But again, that's just a library that somebody created. It's not really a standard. So you take those two things together with having choice of language, having the choice of what you want to use, have something that's a little bit more performant, something that gives you that extra ounce of performance. That's what WebAssembly is. Okay? So we will get to Blazor in a moment, but this is the underlying technology that kind of kick-started Blazor. And ironically, Blazor's actually even gone well beyond WebAssembly. We'll talk about that at the end. But this is a technology that is a standard. Okay? So if you want to look up all things WebAssembly, go to that site. I'll touch upon it a little bit. I'll give you a demo, but this isn't the demo that's going to go complete deep dive into WebAssembly. Just want to give you a feel for what it is. Okay. Key thing again, it's in all the browsers. If you have an evergreen browser on your machine, which pretty much everybody does this day, you already have WebAssembly installed. You don't need to do anything. This isn't a plugin. This isn't something that just one company is championing. Everybody has this. Everybody's behind it. So that's really, really positive. That's a good thing. We don't have this Silverlight idea, okay? If you go to their site, they have these 4 bullet points there about why WebAssembly is good. I already touched upon the efficiency. It's safe. Sometimes people hear about WebAssembly and go, oh God, this is binary code. This means that there's going to be all these manipulations and all these things that people are going to do and break into my system and find all my files and do all sorts of nasty stuff. Okay. WebAssembly works in the same sandbox as what JavaScript does in the browser. So it can only go as far as that. Now, I've already heard recently that people are building WebAssembly and it gets reported as malware because they're doing Bitcoin mining on people's machines. I look at that as they're just being opportunistic. If they can build something that's a little faster in WebAssembly, well, let's download that on everybody's browser and do more mining on everybody's machine. So if you go to some site and you're like, why is my fan on? Well, maybe that's why. But that's not malware in the sense of they're going through and breaking into your machine. WebAssembly is safe, or as safe as anything else you could do in JavaScript. Okay? And it's also open. It is a standard. It is owned by W3C. Okay? You can think of WebAssembly, if you're a .NET developer, which I'm guessing pretty much everybody in this room is, if you've ever dived a little deep into the assembly that's created and look at IL, which is the intermediate language, that's what C# actually compiles to. It doesn't compile to native code, it compiles to IL, and then at runtime, that's turned into assembly code. Okay? That's kind of what WebAssembly is. Okay? And WebAssembly is just a little bit less featured. IL has a very strong notion, a very rich notion of types. WebAssembly has 4 types. int 32 and 64, float 32 and float 64. That's it. So that doesn't sound very powerful. But we can do a lot with ones and zeros, right? We're very creative. So let me show you just a quick example of what WebAssembly looks like. I don't intend or anticipate anybody's going to start building applications like this unless you really don't like yourself, because this would be painful. But again, just to give you a feel for this underlying technology. Okay. All right, so I'm going to go into Visual Studio, and I'll make sure this is the one that's set. I'll zoom in on this one. Excuse me. This is an ASP.NET Core application, but that doesn't mean you need ASP.NET Core for WebAssembly. This is purely a mechanism to host files. That's all this project does. Okay, so just to be clear, this isn't .NET specific. It's just a web server. That's all I'm doing here. And what I'm serving up here are a couple of things, a WASM file and some HTML files. You also see a .c file. Okay, and I'll show you what that is in a moment. I am not a C developer, okay? I did C, the last time I did C was when I was in grad school for my master's thesis. And if you actually looked at the code that I wrote, you along with me would scream in horror. I've looked at it, I'm like, what in the world was I thinking? But I got my degree, so hey, it was good enough, I guess, right? I say this because I'm not trying to do anything crazy in this code. This is the same thing that I did this morning with that collapse conjecture, that sequence. So it's just a simple way for me to generate a sequence and do some work as an example. Okay? So I start with this C file. Okay? And that's about the safest C code I could possibly write without doing any damage. Okay? And if you squint hard enough, you can see what I'm doing is I'm not actually capturing all the values in the sequence, because WebAssembly sort of does have the notion of you can kind of get an array out of WebAssembly, but it really has just these notions of these types. So I said, well, what I'm going to do is return the count of how many elements would have been in that sequence to converge down to 1. Okay? So I run the algorithm, which basically says if it's even, get the next number by dividing by 2. Otherwise, multiply by 3, add 1. And hopefully they all converge to 1, because that's what the conjecture says. And then I return how many elements were generated. Okay? Now, how do I turn this into WebAssembly? You can get all the tools and the tool chain installed in your machine. I'm lazy, so I didn't want to do that. I'm like, what's the simplest way for me to do this? And thankfully, people have already created things online that you can use if you want to experiment with this. So I took this code and I just came over here to this website called WebAssembly Explorer, dumped in the C code and said compile. And down at the bottom here, it's saying that it was able to take that C code and create what's called a WASM file. That is the WebAssembly module file. Okay? It also sticks in the middle here what they call WAT, WebAssembly text, or WebAssembly text. I'm not going to go through it and read it. It gives you, like if you've ever opened up a assembly in .NET into tools like IL disassembler, you'll see something that's kind of akin to this. It's not like all the hex codes and everything. It gives you a little bit of a textual representation of what's in the file. Same thing here. So if you read this, you can kind of squint hard and go, oh, I'm kind of doing a, there's an add in here and there's a multiply in here times 3. So it took that C code and turned it into what I need for WebAssembly. All right? So then I download the WebAssembly file. I already have it on my machine. That's, if I go back to my content for this web server, you can see that file's already there. Okay? And the C file never is downloaded. It's not like that's compiled in the browser or anything like that. Okay? That was just a vehicle to get this. Now, how do I actually use that in the page? So that is this first HTML file, which this will show you my UI skills, which are none, but at least I'll be able to demonstrate how this works. So what I'm going to do is I'm going to have a button that when I click it, I'm going to call this function. Okay? And that function here, I just do an alert, and I have this WASM exports collats 12. So what is that doing? Well, when I load the page to load a WebAssembly file, I have the link here on purpose because you have to kind of do a little bit of gyrations to actually get it so that it's downloaded and the browser has the module file, and then at some point you can actually take all the exports. What are the exports? Well, if I come back here and look at that text version, the function that I created in C is exported so people can call it, okay? So that's what I'm getting here is all of the exports from my WebAssembly module. Once I have those here, then I can actually call .collats. I can call that function with a value and then tell me how many iterations occurred. So if I run this, and that's right, I got to put in the HTML, zoom in a little bit on that, say run, zoom in on that, and you see 9. Okay, so if you counted all these, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it did the right thing. Okay, hold on just a sec. All right, so that's a simple, straightforward example. You can kind of play with it and tweak it a little bit because I was interested. I'm like, I actually want to see the sequence. So one way you can do that is by tweaking the WebAssembly so that you're passing in an import function. I won't show you the text of it, but the resultant HTML file that I use to test this out changes a little bit. I still fetch this different WebAssembly file that I create, except in this case, I'm also passing in this import object. And this defines callbacks that I need to give into the module so it can call back to me, okay? And when this happens, what I'm going to do is simply push a value that's being calculated at every iteration and stuff it essentially into an array so I can report that when I'm done. So now when I click the button, what I'm going to do is just essentially capture all those values and do an alert. So in this case, when I say collats with callback, now if I click the button, you see I get a little bit of a better answer, something that's a little easier to see, okay? Now I admit, this is simplistic, this isn't earth-shattering, but notice that this isn't JavaScript. This is literally C code running in the browser, okay? So the whole notion that JavaScript is the only one way to write web applications has been false since 2017. It's just going to take time for that to start to percolate and really get into people's loop as they do development, okay? So any questions just on how this works? Okay. Zoom back out, go to my slides. Now the reality is, with WebAssembly, I love this quote because just like what I said with IL, nobody, okay, let me ask, has anybody actually done that in C#, like looked at your assembly and dove into IL and did all, does anybody actually even know what IL was before you came here? Okay, so yeah, a couple people. It's not something that's common. And the same thing with WebAssembly. Building these modules is just gonna be a part of your tool chain. It's just gonna be something to say, I want to target WebAssembly. And that's it that you would do. You let all the people that write compilers and everything else, they're going to do the hard work for you. Okay? So it's good to know that it's there, but it's not something that the vast majority of people are going to have to deal with directly on a day-to-day basis. That being said, there are already websites out there that are changing how they do things in their pages, especially if they need to do some fairly high-performant things. And they're building WebAssembly components that they can use in their pages. Okay. What is out in browsers also, I want to iterate this or state this, is it's still a 1.0 version. Okay. There is a roadmap. They do talk about other features that they want, but they're still not there yet, though some of them are in preview for some of the browsers. So the main ones to keep in mind is there is no garbage collector in WebAssembly, which we know .NET has one, but that's not that's not necessarily a limiting factor. It doesn't have any native notion of threads, though you can fake threads on one thread if you do scheduling or whatever underneath the scenes. And threading is actually something that is, I think, a feature flag thing in Chrome that you can enable if you want. So to actually have native support of threads. It also doesn't have native DOM access. So you can't talk directly to DOM elements of a web page. But that is something that they want to add in so you can do it within WebAssembly. Now you still, at this point, you still have to do some kind of JavaScript interop in some way, shape, or form to have your language that's compiled to WebAssembly talk to elements in a page through JavaScript. But at some point, that will become a native thing, and then that doesn't need to be done anymore, okay? Okay, so that's all great about WebAssembly. And there's already a lot of support of varying degrees in other languages so that they can target the browser, okay? C, C++, Rust have had it for, I think, the longest, and there are other languages that have support as well. That's all great, but, we're at VS Live. We're at a .NET conference. We're talking about Microsoft technology. What about C#? As soon as I heard about WebAssembly, I thought, somebody somewhere is going to start to try to build something so that C# can also, come to the party and start playing and having fun. And lo and behold, this thing called Blazor started to come up. So there's a guy at Microsoft, his name is Steve Sanderson. And if you ever use Knockout.js, apparently he was the person that created Knockout.js, he started playing with this not any like the .NET Framework or .NET Core. He actually found this version of a .NET runtime that was an experiment that somebody wrote. It was on GitHub, and it was all in C. One of the things about WebAssembly is if your language can target LLVM, it can automatically be done in WebAssembly. You can then go right to WebAssembly. So all this code was in C. C can target LLVM. That can go to WebAssembly. Hey, this is a start. And so start building on this experiment of having this little runtime and starting to see, could I load assemblies? Could I get the runtime to be built in WebAssembly? And started to get some demos out there and built more and more on top of it. Okay. So it started becoming this experimental project at Microsoft where there's a little bit more support behind it, but they were very adamant to say, we don't know if this is where we're going to go. We don't know if this is really what people want to do. So we're throwing it out there and see what the feedback is. Apparently the feedback was pretty good because at some point it went from this site on GitHub, which was the experimental site, and it went directly into the ASP.NET site. And then they announced, hey, guess what? Blazor is now an official preview. So when I saw this article come from Microsoft, I kind of jumped for joy and partied a little bit. Because up until that time, if I was showing people Blazor, I had to always caveat and say, this may not end up being a thing. You might be excited and go, wow, this is really cool, but I can't tell you that in 6 months, Microsoft may just say, nope, we don't think it's worth the investment. But they have decided to stand behind it and that they are actually supporting Blazor as a full-featured framework, okay? There's devil in details, though. So right now with Blazor, if you, let me rephrase that. With Blazor, at this point in time, what is supported is what's called either Blazor Server or Blazor Server-Side, okay? And if you were in my talk this morning for .NET Core 3, that's what I kind of showed, okay? And what is the difference between Blazor Server and Blazor WebAssembly? One of the cool things about Blazor is, well, it's built on Razor, which you may or may not like, but they took the Razor syntax and basically built a model where everything is a component. You'll see this when I show the example. Everything in Blazor is a component. Components, you can take components, put them in other components, and that's how the whole model works. That's great. It also is really good because the way they design this is the rendering of the output doesn't necessarily have to be in the browser. It can be, quote unquote, anywhere. So what they did for the first version is they said, well, we're still not quite comfortable with what's in the client-side version, but we really think this is a model that people should start getting into. So what they did with the server version is say, you can start building Blazor apps, rock on, but what's actually happening is all the interaction between the client, let me be more specific, components and interactions in the browser actually go through this magical SignalR channel back to your server. And then that's all that code's done there, and then results are sent back to the browser. So in that case, C# doesn't actually exist in the browser. It's all done server side, okay? Which is cool. Somebody actually came up this morning and asked me, so we're already doing stuff Blazor server side. Are we going to easily be able to switch over to client side? Absolutely. That's the intent, is that all the component code, all the Blazor-based stuff that you're doing will easily move over to client side. And I know the cynics in here will just say, yeah, it's just a couple switches, but that's really the intent. You're going to say, we're not doing the rendering server side, we're doing it client side, so we're going to reference this other JavaScript file, change a couple of other things and start up and program CS, and that's it. Okay? The rest of the code's going to stay the same. So if you're a little squeamish about waiting till May of 2020, which is now, what, only 6 months away, 5 months away, and even though it's in a preview mode, that it's not fully supported yet, you can still build them server side and then switch over when that actually becomes a thing. Okay? I have already noticed sites that are not waiting. They are already building production sites that are front-facing to anybody out in the world, and they're targeting Blazor client side, Blazor WebAssembly. You can tell because if you look at the network traffic, you will see the assets that are needed for Blazor client side to work. So some people are okay with this and okay with living on that bleeding edge, so to speak. Some of you may not, or where you're working, they would not want this, and that's understandable. Okay? But I also, when people have fear and trepidation with this, I say, yeah, but how many 0.x packages and modules from NPM is your application using that has absolutely no support from these 5 people that are building something cool, but they're nowhere near the level of support that you could get from Microsoft. So people do that and they're okay with it, but they hear that this is in preview and go, oh, no, this is gonna, this will break us if we do this. Not necessarily, okay? So don't necessarily fear that it's still in preview mode, the client-side stuff. Another thing to keep in mind, and I have names of companies here. I'm not promoting them, and that's not the intent, nor do I work for them or make any money. I'm only showing them here because these are ones that I think people that do web development, especially if they're in the .NET space, have heard of these companies. All of them already have Blazor support for their suite of controls to varying degrees. The point is, they are already moving towards this model, anticipating that people are going to start to do this more and more. Okay, so that's also very encouraging. And again, Blazor works, server, client side, doesn't matter. Okay? So I'm going to go through another demo here. This will be a little bit more in depth on Blazor. We're going to kind of do a couple of weird odd things. I'm still going to use that sequence idea. I'm going to try to figure out where I am in the world when I run this, because that doesn't sound creepy at all, okay? What I'm trying to do is show that if I try to find the location through the geolocation in the browser, I can't necessarily just do it and find it. That would be a security violation. I mean, that would be awful. That would be a bad thing. So I can still do that, and when I run it in a browser that I've already done it in, you won't see the notification, but I'll do it in private, like in an incognito page, and then you'll see, hey, do you want the app to do this? Okay? So we'll do stuff with geolocation. I'll do the calculation, and I'll also use chart.js, because I want to not just show you a list of numbers, but I want to show a nice, pretty line graph of how this sequence converges to one. And chart.js is a library that I think a fair amount of people have used in web applications. This is going to be a truism for a long time, that JavaScript is not just going to die off because this thing is so cool and awesome, even though maybe some people would wish that. That's not going to happen, okay? There's going to be libraries out there that have a lot of cool functionality, and we need to interop with that kind of stuff. So I'm going to use chart.js to do that graphing and put those numbers in a nice, pretty line chart, okay? So let me get onto my chair here. Now, if you notice at the top of Visual Studio, again, I'm in preview mode, so I think that's probably, you can try to maybe finagle this into, just Visual Studio 2019. It may or may not work. It's recommended you just go with the preview version, okay? And when you get the preview version, it's going to install right now .NET Core 3.1, which is currently at preview 5, I believe, and it already has a go live license. So 3.1 is good from that perspective. 3.1's actually been targeted to release either this month or next month, okay? So, excuse me. But for Blazor itself, you definitely want to use the preview version of Visual Studio. The other thing I want to point out is if I actually go to blazor.net, and let's zoom back out here, so it's a little bit saner. Highly recommend to go to blazor.net. It redirects to this site, and if you go to Get Started, it will describe some of the things that you need to do. One of them is this, because when I show how to add a new project, you may go, I don't have this template on my machine. I don't have this project template. So run this command here from the command line, go back into Visual Studio, and then you should see the Blazor WebAssembly project template, okay? All right, I have already done that, but I'm just going to go through and just show if I say File, New, Project, and I type in here Blazor. Whoops, I did that too fast. You can see in the top here, what you should see is just Blazor app, okay? Excuse me. I say Next, I would say Console 19, and unfortunately when I do this, it's going to unload my solution. I'll have to reload it, but that's okay because, that's not what it should have done. That's not what it should have done at all. Let's do that again. Preview. Okay. And I will say, it will listen to me this time. Create a new project. Blazor. Blazor app. Next. And yeah, the looks look good. We'll say create. There we go. Okay. Wow, that's looking really bad. It's supposed to be the other way around. I'm not sure why it's doing this. It should say for ASP.NET Core 3.1, these WebAssembly templates are there. I don't know why it's getting a little confused and saying it's 3.0. But see, this is when you do stuff in preview, you can just kind of go, not my fault, it's preview, okay? So if it's not quite perfect, I'm not sure why. But you should be, when you install that template, you should actually want to use the WebAssembly one. The server one is for that server-side version of Blazor. And I'm just going to ignore that now because the cool stuff is the client-side stuff, okay? So let me go back here and we'll do preview, and let me just bring in my project that I already have ready to go. And there we go. Okay. So one of the things I also want to show here is I have that implementation of that mathematical sequence generation, but I did it in C#. And it's in a project that is also targeting .NET Standard 2.0. So this is also trying to illustrate that I can reuse this implementation in other project types where the runtime can support .NET Standard 2.0, okay, which is cool. That's something, just as a side note, as you're developing code these days and you want to make sure that you're targeting as many different kinds of frameworks as you want, .NET Standard, if you're not doing it like as a console app, you want to make sure that you're probably targeting .NET Standard so you can say I can run in Xamarin, I can run in Mono, I can run in .NET Core, and so on. As time moves on, like I talked about this morning, the need necessarily for .NET Standard may taper off over time, but for now, it definitely allows you to have more targeting capabilities with runtimes, okay? So in this class, I just passed in my initial value. I use a big integer because I don't have to be limited to just 4 types. I can use something that allows us to put in huge numbers if I want to. I am also going to use an immutable array, and once I build up the entire sequence, then I'm going to actually return an immutable array back to the caller. Okay? So we're already seeing a much richer environment because we're in C#. This project here, this one is the one that's generated as the Blazor WebAssembly project. One of the things I noticed when I created this and I hit my enter key on it, because I wanted to look at the project file, is it's targeting .NET Standard, but it runs as a web application on the server because it at least has to host enough to get it shipped over to the client. So I'm like, how can .NET Standard 2.0 actually be like a runtime target framework? That doesn't exist. So there's magic being done here. What actually happens when you run this project is it ends up being hosted in a console app, so to speak, and that's what's actually run and executed when you run this project. Okay, so it looks maybe a little silly, especially if you know what .NET Standard is or what it really isn't, but that's the way it's working now. Okay, it also adds in all the current packages that you need, and as you can see, they're all preview right now. So, but they're all added for what you need. The dev server package reference is what does that magic to actually host your code, and then it gets it shipped over to the browser. Okay. I'm also referencing my core project, so I can use that sequence generation and show it in a web page. Excuse me. So the next thing I'm going to do is kind of start going through from the index HTML and finally get to the page that actually has that sequence generation. So if we go into www.root, some of these are already set there. They scaffold up a page for you using Bootstrap. And if you look through a lot of Blazor examples, pretty much everybody I've seen uses a scaffolding because you end up with like a menu option layout on the left. And then as you click on those, people just create their own components and have them showing up on the right to try things out, okay? So some of this is stuff that is just ancillary to having a Bootstrap app. The index HTML is what's generated here. And I've added in just a couple of things because I want to have Chart.js support, so that's what that link is there for. And then I also have this JS file. This is a CSS file. This is the JS file for Chart.js. Then I also have 2 JS files that I'm going to need to get geolocation and also support Chart.js interop in my app. This one is added automatically for you. This is kind of the kickstart catalyst in the browser to say, hey, you need to do WebAssembly stuff. This is what Blazor gives you out of the box. And so it's going to start downloading things for you, get the runtime there, get your assemblies there, and start loading components so they show up correctly in the page. Okay? So you could tweak all that if you want and maybe give a little bit of a better experience when the page first loads, but what's really key there is that Blazor web server JS file. That's the one that kickstarts everything. Okay? The program and startup files, those are also auto-generated. I didn't do anything to these, maybe just clean them up a little bit. But you can see here that the host is actually a Blazor WebAssembly host. Okay? And the startup here, this also kicks off things that are now in the browser in .NET to start getting the components to show. Because once we have the runtime for .NET there, it can start actually running .NET code, and Blazor is just, if you see the program and startup files here, if you've already done ASP.NET development, these files and the way things are configured should be pretty common. This is nothing new here. Okay, it's just tweaked a little bit so that we can have Blazor as the thing that is started up when the project runs. You can also see up here that there's using dependency injection. So because this is just a .NET app, everything that you've ever been able to do in .NET can easily be done in Blazor. So dependency injection is a first-class concept, and we're going to use that for JavaScript interop when we need to do that in our components. Okay? So most of that is just kind of coarse scaffolding, and you can play around with this stuff, but the real cool stuff is in the components themselves. Okay. So the shared folder will have a couple of, let me actually zoom in on this so you can see this, these .razor files. Okay. So again, Blazor is all based on Razor syntax, just tweaked a little bit for Blazor. So if I open one of these up, you'll see that it's just all HTML, nothing special or proprietary or anything like that, except you may see here, @onClick for a button calls that method, okay? Or the class for this div is based on that property, okay? So where are these things? Down below is this code directive, okay? And you'll see here that that's what that nav menu CSS class is, just a string. So based on the value of this Boolean, it's either going to tell you to collapse it or not. And how is that determined? It's based on when that toggle nav menu is clicked. Again, this is just generated by the scaffolding, but it's trying to show you a little bit of, you can already start to do some dynamic changes in your web pages and HTML elements through C#. Now, of course, there's a little bit of magic going on here. I said that WebAssembly doesn't have native access, direct access to the DOM. So what Blazor is doing underneath the scenes for you, when you see something like this, it feels like, oh, when the HTML button is clicked, it's calling my C# code. There's a little bit of JavaScript interop there that you don't see to get it to the point where it's actually going to call that C# method. Okay? If you're really curious, you can go dive deep and see how that works. But at the end of the day, I'm just a developer. I just want to get stuff done. That's what the framework has given me. So I'm just going to say on click, call that method, and I win. Okay? So that's the navigation menu component. I'm going to keep saying that. The main layout is the one that actually defines that on the left is the nav menu, and then the body, the content, what you navigate to is going to show up on the right. Okay? And then that menu option here, the menu here, the options that show up here, this is what people kind of tweak. They'll keep taking this element and just keep copying and pasting it or moving it in and out just to, try out different things. To be clear, this isn't saying that you have to use any of this. You don't have to use any of these scaffold templates and components. You can take this as just kind of a guide and build your app to work any way you want with HTML. If you already have a site where you already have all your HTML assets, you can just start taking and copying, pasting them, and putting them in Razor files, and then start putting in all the places where you want to do these HTML interactions. Just kind of like what you do with Angular. It's very, very similar to that. Okay? This navlink component is also from Blazor, and it allows me to literally navigate to a specific href. Okay, so Blazor has routing in there. When I click on this navlink, it's going to look for something that supports this sequence route. So I can go to my custom sequence component. Okay? What does that component look like? That's this one. Okay, so let's start stepping through this to see what this is actually going to do. So you'll notice at the top I have 2 page directives. Excuse me, the route that I had in the nav menu href, that's the one that when that navigation menu option is clicked, it will route to this component. I also have a page directive that says if I pass in a value on the route, I can directly go and just process that value for my sequence. So you can put multiple routes on a component, and depending upon what's put into the route, it can do different things out of the gate. Okay? I'm also injecting, well, I should say I'm not injecting, something is injecting into me into the component, something that supports IJS runtime. So if I wanted to, I could go back into my startup files and register all sorts of other dependencies that I need that would work perfectly fine. No difference. There are a couple of dependencies that are automatically registered for you when you are using Blazor. This is one of them. So if you need to do any JavaScript interop, you just do what I'm showing here to get a reference to that JS runtime. And you'll see in a moment how this becomes relevant when I need to actually talk to JavaScript and for it to come back and talk to me. Okay? There's this geolocation component. I'll come back to that later on, but this is something I could have just inlined here. But Blazor's components, the intent is that you can find reusable pieces in your application, package those up in components, and then just drop and plop them in anywhere you want. Okay? So that's what I've done here with geolocation. This will actually render and show you a map of where I currently am when I run this code. And I'll show you what that does just later on. I have a text box, so people could actually type in a value if they want. Button to say, hey, actually calculate the sequence for me. This will show the sequence as a comma-separated list. This canvas element is there for my line chart that chart.js will render for me. Okay, so if you go to chart.js, you go to their site, how do I render a line? It will say the first thing you need is a canvas, and then it gives you some other just basic documentation to actually put a line in there, among many, many other graphs that chart.js can do. So this is where the line is going to be rendered. Okay? Down in my code here, I have this constant because I need a way to uniquely identify the canvas element and then reference that in JavaScript when I actually want to render the line, okay? I also have a property that's also defined as a parameter. This is needed because when if something calls me with this route, that start value is going to map to this property, okay? So this is how you can capture things that are put into your route and have access to them within your component. This is where the comma-separated sequence is going to be stored. This is where the actual numbers are going to be stored, and you may look at that and go, why is that a list of object? Unfortunately, chart.js knows nothing about a big integer. It doesn't understand what a big integer is. So you have to do these casts for chart.js to get it so it can actually show the numbers that I generate. Okay? This is also kind of showing a little bit of the limitation that we would have potentially with some JavaScript componentry. If I could do this all natively within .NET, then I wouldn't have to have something like this. But this is the only way I could get it to work with chart.js, and you'll see why when we get to the actual rendering of the line. And then these labels are just generated to have like a label on my x-axis for each iteration that occurred. On after render async. So there are a whole bunch of lifecycle methods and things that a component goes through from the time it's first instantiated to the time it goes away. And if I type in here override and zoom in on that, you can kind of see some of them there on initialize, parameter set. The reason I have this one overridden is because this is essentially the method that says pretty much everything's ready to go now in your component. So if you want to actually look at your parameters and see if something was set there, then you can react to that thing, that event happening. So in on after render async, I look to see, was start actually set? In other words, was a value passed to me in the route? And if so, then just go right ahead and start calculating a sequence. If not, I'm going to have to wait till somebody types it in, okay? And if somebody types it in and hits the button, this is the method that's called. And again, this is one of the few times, in fact, the only time where an async void is okay, is when you do an event handler. Okay? Otherwise, async void is verboten, you should never do it. So this goes to, it basically just redirects right to create sequence async. And that's where the calculation is actually done. I first check to see if what's in the text box or what was provided in the route is actually parsable as a big integer. And if it is, well, then I'm going to use that class that I showed you before to actually do the number generation, the sequence generation. Assuming that's okay, then I'll create that comma-separated list of values. I'll then do this kind of gyration to get the values cast to objects, so chart.js will be okay with it. I'll create all the labels here, so I just use enumerable range and end up creating a list of labels from 1 to however many they were created. And then I'll say status changed. This is where in your components you can tell Blazor that, hey, some things internally have changed in me. You may want to know about it, so then you can update things in the UI or other components that exist. Then I also do this update chart, okay? And what is update chart doing here? This is where I'm actually going to go off and call some function in JavaScript to tell it, go ahead and draw a line. So where does that function actually exist? If I come back up here into www.root, you'll see this charting.js file. And this is how you can do interop within Blazor. Some people may not like that you have to actually attach your method to window, but this is the default way to get things to work, and hopefully you don't have lots of things to pollute window to do interop with. But this is where update chart is defined. So I pass in the ID, the canvas element, the data, and the labels. And then this code is pretty much I just grabbed this from chart.js and said, put in the chart, okay? So I calculated all these values from C#, and now I have chart.js graphing them for me. And what about that geolocation thing? Let's go back to that one. So this is that geolocation component, which is defined right over here. It also needs a reference to the JS runtime because it also needs to do some JavaScript interop. All this stuff is the lat, longitude, and accuracy, and this div and iframe I stole from this site on Bing. So you can go to bing.com and say, I want to embed a map, and it will literally generates this code for you. I took a look at it, looked hard, and where you see where I'm doing on the source and the hrefs, where I'm binding to these URL values, that's where you get this kind of long string in there where Bing uses that to actually show you the map. But I saw in there latitude and longitude values, so I said, if I generate those URLs with the correct values, then Bing will just show magically where I am. So kind of cool. All right, awesome. So then I just have to figure out, where am I? How do I know where I am? And I don't mean as a philosophical question either. Where literally am I in the world? So the way to do this is to use the geolocation API in the browser. But it needs to tell me, once it's figured out that it's okay to figure out where I am, what those values are. So this method is annotated or has the attribute of JS invocable. This is saying to Blazor that JavaScript should be able to make this call. If you do this, you want to make sure that the values that are being passed into this method are ones that JavaScript could actually pass values into. So you don't want to pass in really complex object graphs here. In my case, all I have are 3 doubles. This is going to work, okay? So when I get called back, I capture latitude, longitude, and accuracy, and then I update these URLs that Bing created and sticking in through string interpolation what the latitude and longitude values are. Okay? In this component's initialize async, this is where I'm going to go off and say, okay, try to see if I can get the location through this method. And also notice in this case that I'm passing in a .NET object reference .create to this. This essentially creates a wrapper around whatever object you pass in. In this case, it's the component itself. It's the geolocation component. So in my JavaScript code, if it has a reference to this wrapped object, it will be able to call methods on it that are marked with JS invocable. Okay? So if I go to location.js, this is where that function is defined. And you can go off in here and basically steal the code that I stole, okay? So I go and get the current position. I don't have a callback set up here in case things go wrong. I just assume everything will be right because that's what developers do. And given that it will work, notice what's actually happening here. When I call get geolocation, it's getting an instance as an argument. That's the wrapped object to my component, okay? So in the case of when it works, it's going to call invoke method on that wrapped object and say, I want to call a method called change, passing in lat, longitude, and accuracy. And that's what's going to call back into my component. Let's see if all the magic works. So that should be my startup project. and we'll say a 5. I will say a 5. Are you building? I hope you're building. You're successful. Good. Loading, and there is this template that I talked about before. I'm going to click on sequence, give it a second, and it will figure out what my lat and longitude are. And let's zoom in on that. There's no push pin here, but it kind of looks close to where I am right now, right? So figured out the location correctly with an accuracy of 55 meters. That's okay. It's close enough. Let's actually do a current sequence, and I'll give it 55. Excuse me. So I create sequence. I get the common separated list, and look at that pretty chart pop in. Okay, and I can put in fairly big numbers if I want and make it kind of harder to see, but it all works. All binds to chart.js, everything works just the way I expected. If I come up here to the route and I pass in 55, notice that when the page gets rendered this time, it automatically is drawing the graph because it already knows what the value should be. Okay. And if I take this, and let's just fire it over into Firefox here, so I can show that yes, it doesn't just work in Edge. Okay. Look at what it's doing up here. It's asking me, because when I do it in Edge, I've already given it permission to do it. The first time I did it, it did ask me this question. When I come over to Firefox and I say, pass this value, go to this page, it's doing the right thing. It's asking me, do you have permission? This is again to show that you can't just sneak in and do all sorts of nefarious things. You need the right permission from the user to do this. So I'll say allow location, back out, and eventually it does the exact same thing that you saw in Edge. And this is all happening in the browser. Let me show you from a network trace here. We'll clear that out. We'll say refresh, let it download all the things that it needs to, and at some point, I'll zoom in on this when I get to the right spot here. There we go. You will see Mono.js, Mono.wasm. That's actually the Mono runtime compiled to WebAssembly. And then all my DLLs, both from what Blazor needs and also at some point, unless I missed it, where you see Blazing the Web, core, maybe I already passed it up. Did I pass it up? Yeah, there, okay, I did. So here are my two DLLs, my two assemblies that they're just not .NET standard assemblies. And that's what actually gets executed through Mono WebAssembly. Okay. Yes? Will that not run on a mobile device? It absolutely will. Absolutely will. If your browser on your mobile device supports WebAssembly, which I have an Android, and I've actually gone to like my sites or other sites that are done in Blazor, they work perfectly fine. Yep, they all get downloaded. No, you don't need anything installed. Okay. Now, to be fair, I'm not showing the sizes here, but that's one of the things right now that they're very concerned about with the size of Mono.wasm. I think they have it down to 1.9 meg. Some people hear that and go, oh my dear God, you're telling me to download 2 megabytes every time this app runs. That's a truism the first time. Once it's there, I don't need it anymore. And if I do things like CDN on Mono.wasm, then once somebody does it, then nobody else has to do it in the browser either. Okay? They're still trying to find ways to do tree shaking and other things to get a very slimmed down version of Mono.wasm. It will have some appreciable size, but I've also, to be quite honest, I've seen web applications using JavaScript libraries where the footprint is astronomically big. Okay, so I'd also say to that, I really don't know if it's truly going to be that big of a deal depending on what you do. Okay? Yeah, one more question, then I'm going to finish up. Go ahead.
Do you know why they choose Mono?
Why did they choose Mono? A couple reasons. I'll give you the short answer. Primarily because they had already started doing work with Mono to target WebAssembly a couple years ago. So it was kind of already ahead of the time. And so that's why they're using Mono right now. Could you possibly use the core CLR or like .NET Core's runtime? There's no reason why you couldn't. It's just that this was already getting support built in, so that's where they're using it. At some point in the future, would they switch over to .NET Core? Maybe, maybe not. Okay? But that's primarily the reason why right now. Okay? Let me finish off on a couple of things, and then we'll be done. So just to reiterate, one of the cool things about Blazor and WebAssembly in general is it's meant to give you faster performance, even if you're not building games. It's all binary, and it's intended to give you a faster runtime experience. The thing that I think is really cool, though, especially with WebAssembly, and is shown through Blazor, is the notion of freedom, okay? The notion that I'm not tied to one language anymore. And to illustrate this further, if you've already seen this when I've done this, maybe I've done this before, you've seen me do this before, you've already looked at the slides. If you know the answer, don't answer. But this is a graph from a site called Tiobe. And Tiobe does something where they try to graph the popularity of languages over time. It's not perfect, it's not completely objective, but it does as best of a job as they can to see what's popular in the world for what different languages. So this is a graph of a particular language, and if you can't see the number, the y-axis doesn't matter. The left one, the x-axis matters a little bit more, and it's a little bit hard to see. If you can't see it, I'll just tell you that it's flat until about a little bit after 2009. And then it starts going up and up and up and up and up until about 2014, and then it starts to fade and just kind of taper off again around 2018. What language is this? Give a guess.
JavaScript.
No, it's not JavaScript. It's not C#. How dare you? It's not C#, it's not COBOL. It's not Java, it's not C++. Oh, it's Objective-C. Okay. What happened in 2009-ish? iPhone. Okay? This thing called an iPhone, you might have heard of it, came out. And all of a sudden, an admittedly really cool device comes out, and people want to jump on the bandwagon and build apps. How could you build an app on an iPhone? Objective-C. Okay? And I did this in 2008 or 9 or whatever it was. We had a client, wanted to do an experiment. Can we, let's do a proof of concept. I had never touched a Mac in my life, I will admit it. But I'm like, I want to try this. Hey, cool thing, right? Developers like to try new things. So I'm like, sure, I'll go on a Mac. Sure, I'll try Xcode out. Sure, I'll try Objective-C out. And I did it after a month, and I will tell you that after a month, I do not ever want to code in Objective-C again, okay? That is my opinion. You may love Objective-C. We're just going to agree that you're wrong, okay? And around 2014, you started to notice that there were other options. Swift, Cordova, Xamarin, other ways to build applications on an iPhone, and then the popularity starts to go down. Apparently, people like choice. People like to use languages that they really do like. And I think this is also true of JavaScript and things like C#. I don't expect WebAssembly to completely kill off JavaScript. Hell, you've probably booked a ticket to get here on a plane, and somewhere COBOL was in that processing pipeline. I guarantee you it, okay? Languages, runtimes, they don't die. They just get hidden in a server room somewhere. So I don't expect JavaScript to just die. I do think that over time, when not just C# and Blazor, but other languages start getting more and more support, that the prevalence of JavaScript is, I believe it's going to start to lessen. I could be wrong, but I think it's going to start to lessen. And one other quick thing that I'm going to demo is this idea that WebAssembly almost becomes the way to start doing, or a really cool way to do language interoperability. If you can have all these languages target WASM, WASM is a very, it doesn't have a whole bunch of stuff in it. So it becomes pretty easy then to map that into what a language needs. WebAssembly is essentially a subset of IL. And so what this person did on this project is said, you know what, let's do this. So this is kind of a little bit of an experimental thing. But what this person did is created this WebAssembly runtime package. And what you can do is, through that person's API, give it a reference to a WebAssembly file. And it will turn that into IL, or an assembly. So then you can go off and guess what? Invoke functions that are exported on that WebAssembly. Because now they're just .NET functions. Literally, this isn't like any type of interop layer at that point. It is truly a .NET assembly at this point, the line that I have highlighted. So if I run this, guess what happens? I see a 6, because it took 6 iterations to go from 10 down to 1. So if we all start targeting WebAssembly, and you're building code from Rust in WebAssembly, and you're doing it from Swift in WebAssembly, and I'm doing C# and Blazor in WebAssembly, it becomes a possibility that we can interop with each other much, much easier. That's a really cool idea. And Blazor itself, in conclusion, Blazor itself is not just sticking to HTML. If you look at what Blazor is doing with their latest updates and videos that they produce, where Steve goes off and says, here's the latest and greatest of what I'm doing, they are not just targeting HTML. They're looking at how can we build progressive web apps with Blazor? How could we potentially target Flutter, if you can believe this, with Blazor? Maybe we can just target .NET Core directly, or we could do this with Electron, but instead of Electron coming up with some of the extra baggage, we'll just use .NET Core and deploy Blazor apps that way. So this is really becoming quite interesting with Blazor. Because what I just showed you is, I think, well, maybe not what I did is cool, but the fact that I could do it in Blazor in the browser, I still get chills. I'm like, this is so cool. This is awesome. And yet, we may be able to take, we being Microsoft, and we just go along for the ride, is to use Blazor to almost become possibly the cross-platform UI solution from Microsoft. I don't know if that will actually come. Some of these things are definitely experimental, like the Flutter thing that Sanderson has shown. That's very experimental. That's not even a supported thing yet. But they're trying things out. Okay? This, to me, is extremely cool. And I'm looking forward in the next couple of years to start building. I kind of went away from web app development for a while, especially when Silverlight died. And I kind of just hung out in the middleware area for .NET for quite a long time. And now with this coming up, I'm starting to get really excited again to start going, yes, I want to get back into building web applications and do it in C#. Okay? So I'm pretty much at the end of my time. If you have any other questions, feel free to come on up and ask them. Try to answer them as best as I can. Otherwise, I am done. Thank you for coming.